Hey everybody, I'm David. I'm going to be showing you how to find some key coordinates of this graph. I want to get some key coordinates of this graph. So it's really all about the evaluating of the log, If I can come up with some nice numbers that I can put in and evaluate that log, it makes this easy. Now straight out, if you're doing this on Delta Math, do what makes 0 with the inside of the binomial. What makes 0? What x makes 0 here? Looks like x is a positive 3, if I'm not mistaken. That'll make 0. Minus 3. Yep, cool. And we're going to move the asymptote right 3. So now we've got an asymptote that's going to be at x equal 3, right 3. And if you're really just want a shortcut to this, you can go to Desmos. And you can actually just look up the table and grab 2 coordinates. But I feel that leaves out so much of playing and really enforcing your understanding of logs, order of operations, evaluations, some really important stuff here. Okay? So hang in with me here. Let's just play with log base 4. What number would be really nice to put in there to be easy to evaluate? For instance, if I did 4 to the 0, I would have 4 to the 0, and that would be a 1, right? That would be an easy number to evaluate. If the log base 4 of 1 here, that evaluates to 0. So then I would plug in a 0 and then evaluate to get the rest. Let's play with another one. What if it was log 4 of 4, which is 4 to the first? Well, you know then that this evaluates to a 1. 4 to the 1 equals 4 to the 1. So I could keep going here and pick out some other ones, but if you notice, I'm picking nice numbers that are easy to evaluate, that easily come out of the log. The evaluation of log 4, 16. Now that's 4 squared, right? That's 4 squared. So what number was I really shooting for the evaluation? Well, it was a 2. So if I can get the inside of the parentheses equal to 4 to the 0 or 4 to the 1, right? 4 to the 1, that's a 4. Or if I can really get it equal to 16, okay, then the log would evaluate, plug and chug, to these numbers, 0, 1, and 2. That's the key to this. That's, to me, where the playing is, where I think you'll get brain growth, and you know how much I want that. Again, in a few minutes, I'll just put this on Desmos and show you how to cheat. Okay, because I saw that's what the Delta Math teacher did. I saw that's what many teachers do. They eliminate the playing and they just get to the graph. Well, we have Desmos. We can graph it that way, right? So how can we get these key dots? How can we be clever? So negative x plus 3 is equal to 1. Let's solve for x. I'm going to do, what's that, 2 steps. I'm going to subtract negative 2, and then I multiply by a negative and get a positive 2. Cool? I'm going to subtract, okay, minus 3 gives me a 1, right? And then a negative 1, multiplied by a negative. I'm going to subtract, okay, that's then 13, and then multiply by a negative 13. So now I know I've got 3 x values, positive 2, a negative 1, or a negative 13. I don't think I'm going to bother with this other one because I only need 2 of them, so I'm not going to do this last one. So now let's plug and chug a 2. Let's evaluate f of 2. F of 2 is equal to negative 3 times the log minus 4. I ran out of room right there. Let me find some more room over here. F of 2 is equal to, forgive me, get rid of that real quick. f of 2 is equal to, let's plug, okay, be meticulous, -3 log base 4. I'll plug in the 2, negative of -2, plus 3, close that log down. Order of operations says we've got to do this whole entire log first. This entire log has to be done before multiplying and subtracting. That's order of operations. And knowing that log is an exponent kind of helps. Order of operations starts with a P, PEMDAS, parentheses. So you got to do inside the parentheses very first. And that would be -3 log 4 of 1, and then a -4. Again, it might be good to put brackets, parentheses. I always say chunkify it. Okay, evaluate. You ready? What is log base 4 of 1? We already have that evaluation. That's why I chose that number. 0. So now I have -3 times 0 minus 4. That answers -4. I have found the y coordinate. I have found the y coordinate by plugging in the x that I logically found. All right, let's evaluate f of 1. F of 1. Now, I can do this a lot faster, right? Because I know some things. I'm the one that created the -1. So I know if I plug in -1 into x, it's going to give me 4. And I know that if I get an evaluation of log base 4 of 4, it's going to give me 1. So I'm just going to jump the gun here now. To plug and chug -1 means I'm going to get -3 times log base 4 of 4, which is 1, minus 4. Whoops, no parentheses there at the end. All right, so what is that? -3 times -7. Woohoo! I've got the 2 dots. I can now go to Delta Math. Go to make a vertical. Slide it over where I said to slide it over. What did I say? +3. Move my dots where I said to move them over. Where did I move those dots over? To -4, to -4. So 2 down 4. And then I am going to come back. I need to get that other one. I'm looking at my notes. Please do this in your notebook. That's where it belongs. -1, -7. -1, -7. And that's what the log graph should look like. And if I hit check on this, submit answer, maybe I got it right. I did. New problem. Okay? I'm just going to focus on the middle right here. Wait, let me do a new one. I want to do a different base. Come on. Give me a different, oh, don't go to exponentials. Oh, man. I know. Okay, this is a good one. Good one right here. Log base 5, -x, -1. I'm just going to focus there for a minute. Log base 5, -x, -1. Log base 5, -x, -1. Okay? Now, I want to make the inside nice to work with logarithms. So again, like 5 to the 0, so it kicks out 0. Okay, log base 5, 5 to the first. I only need 2 dots, so I'll stop here. Okay, and this will kick out 1. So I need the -x and the -1 to be equal to 5 to the 0. That's a 1. What's x equal to? Add, multiplied by a negative. And I need the x equal to, the x minus 1 equal to, let's see, the inside there is 5 to the 1, 5. So I'm going to add 6 and multiply by a negative, -6. So 2 nice coordinates that'll kick out nice, easy numbers for this are going to be -2 and -6. I still got to go plug and chug in the main equation to go get the actual y numbers. That to me is huge too. That to me is powerful. That's what I don't want you missing out on. Okay? But I get you're busy. I get that math may not be your thing. I respect that. So I'm just going to go to Desmos and throw this in Desmos real quick. So I'm going to see if I can copy it. Go to Desmos. Okay, start my graphing calculator. Okay, I'm going to try to paste it in. It's off your screen. It won't allow me to paste it in, just so you know, so I got to retype it. 2 log base 5, base 5. Hang on, I got to get a log base. By the way, when you want to do log base 5, it is in the main functions area, and you can pull out a different type of log with a base. There's something called a log base A in there. So if you go to the functions in the on the calculator, you can change the base on the log. It's very cool. Again, functions, go to miscellaneous, and it's right here. Very cool. So now I've got the 2 log 5. I'm going to put in the minus x and the minus 1, the minus x and the minus 1. And now I'm going to put in the minus 8. And I'm going to try to show you something here. Cool. Let's see if that worked. Dun, 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 dun. Sorry about that. You can see I've got it typed in now. And the graph is down there. And I need the key dots. So this is the way that many teachers tell you how to do it. Move the asymptote over, left or right. 1 makes 0. You know that one. And then go get some data points. If you're on a TI, you could type this in on a TI and do table. But I prefer Desmos. And there's my table when I click on that little tools right here. The actual edit list is what it's called. Now, remember what I said about that there's a couple of x values that were going to work here. Remember, we chose some good x values. You can see there's a bunch of x values that are undefined because we went on the other side of the asymptote there. What are those 2 x values? -2 and -6 that I wrote down. So let's actually see if that's true. -2 and -6 should be nice integer answers. And there they are. And there they are. So I think the clever part, really, honestly, is the playing here. You may go ahead and use Delta Math, Desmos, and just get out of it. But this, to me, is really where the puzzle is. And I think this is where your brain will grow. I hope this helps. Have a good day. Peace.